Okay, so this is our I think it's our seventh video or something, but it's our first video of chapter two. So we are officially starting chapter two, which is the math review. Yeah, but we cover a lot of things in chapter two. We start with basically defining a function. It's very easy. Technically, it's algebra one and above. It gets a little bit more sophisticated, but we know what a function is. We kind of have two concepts, a function and their graphs. But if I just kind of say it in a nutshell, we'll talk about this stuff later. Chapter two is just introducing a function, and then it's going to be, calculus one, basic derivatives and the derivative formulas. Yeah. So then we're going to have multivariable functions, partial derivatives, and that's where we get into the real maximize, minimize, optimization. So it's really just a bunch of concepts that are leading up to the multivariable. Okay, so step number one. Now we all know this. It's kind of silly to say it, but function is going to be y equals f of x. Yeah. So here's a function here, and we just want to understand that x is typically referred to as the independent variable. It's independent. Yeah, the horizontal, which is the x, that is going to be the independent variable. Yeah. Okay, so the y, yeah, the vertical is the dependent. They simply call it this because y depends on x. You plug in the independent, you output the dependent. Yeah. So they do call it dependent independent there. Yeah, so we should know that. Uh, Okay, so when we kind of look at these graphs, we are talking about a few things over here. So maybe this is kind of a pretty simple function like y equals e to the x. We just want to use some sort of a example. So we have a basic exponential function or y equals e to the x. We have that. Okay, so we're just talking more about the function. We know that uh, all the x values horizontal, all the x values for which a function is defined is called it's called the domain. Yeah. In here, maybe the domain is going to be negative infinity. We call it all real numbers, or, negative infinity to infinity. That's kind of the interval notation. It should be obvious what interval notation is. I just erased it for a second on purpose. Yeah. But an infinity always gets a parenthesis because it's not a point, it's interval notation, negative infinity, comma, infinity, and parenthesis. That just means the domain is negative infinity to infinity. So this is just silly because it's just a vocabulary here. But what is the range? This is vertical, the dependent variable. We just want to mix them up. Independent, dependent are the same word, basically. So sometimes we mix them up, but independent is x, dependent is y. So the vertical is going to be the y is going to be the dependent variable dependent on x. Yeah. So the range, as we always know, the range is the set of all y values for which a function is defined. Now we're just saying here it takes me a minute to build up to the easiest point. Yeah. But we might not have heard so much about the codomain, not that that's a concept. The range and the codomain are the same thing. Codomain, of course, is just another word for range. So the domain is the set of all x values, and the codomain, which is also called the range, we're more familiar with calling it the range. The codomain is the set of all y values for which a function is defined, or the range there. Okay, so we're just making a couple very simple points. This is so introductory, it's silly, and we can kind of skip it, yeah? But when we talk about a function, we're literally always just talking about the definition of a function and their graphs. So something like this, all that other stuff doesn't necessarily apply to economics. Something as simple as this applies a little bit more to economics. Uh, so the x value, as we could imagine, the x value might be a quantity, supply and demand, a quantity. It could be time, it could be money. There's a lot of things the x values might be, but it should be obvious that in reality, most familiar examples, the x value is going to be greater than or equal to 0. So in a real application, the domain typically is greater than or equal to 0. In interval notation, that's a 0 with a bracket, of course, means including. Yeah, 0 to infinity. I don't know about this over here. That's like set builder or something. We don't care. I don't really feel comfortable writing that. Hopefully I wrote it correct, but usually interval notation. I like interval notation, but it doesn't matter how we express the thing. I'm just being too descriptive about something obvious. But this simple thing here is something more prudent to what we're doing here. Okay, so much more important are going to be multivariable functions. I've kind of done a little thing here for multivariable function. Okay, so not everybody has seen multivariable functions. We don't ever want to be overly descriptive about something that's easy or something. It's kind of obvious what it is. A three-dimensional graph sometimes, graphing it and understanding that is not so easy, but we don't care about that. So what is a multivariable function? It's simply y is a function of two or more variables. So it's very, very easy. Yeah. So y is a function of two or more variables. And it is always, it's typically, I shouldn't say typically, I mean, we're literally saying always. We still have independent dependent. That's why it's so important. But y is, there's always one. What I'm kind of going on about is the fact that there's always one dependent variable. So it is a very, very good way to understand it. And what we're saying is that y is dependent on two independent variables. So it has to be a correct real world example. There has to be a line of reasoning, but you can have as many independent variables, x's, you can have as many independent variables as you want. So that's what a multivariable function is. It's just the dependent variable y is a function of two or more independent variables. And it's just notation. We don't get hung up on notation. Typically, it is a set. I just repeat myself over and over, but typically it is a set of independent variables. So you usually call them x1, x2, not x and y. In a calculus 3 class, maybe we call them x and y. We can't get hung up on notation because it's all the same thing, but this is y as a function of two independent variables, yes. This is z as a function of x and y. Those are the same exact equations, just a different notation. So we're just kind of that's a comma, not a one, comma, yeah, comma, yes. Okay, so here we have it here. Yeah, this is kind of a generalization, yes. But we have y, the dependent variable, as a function of, we're not going to say infinitely many, we're talking about math. So yes, x can go to infinity. We would never have an example like this, but you could have y as a function of 10, 10 independent variables. You can have y as a function, of 20 independent variables. So the independent variables x are like inputs, and there's always only going to be one dependent variable, one output. Yeah. So we've covered that enough, but multivariable functions is just going to be y as a function of two or more variables. So maybe just a quick example. We will often be interested in functions with two variables, y equals a function of x1 and x2. For instance, maybe y equals 4x1 plus 8x2, a very simple equation, can represent the amount of apples y a farm can produce when using different amounts of organic fertilizer, x1, and artificial fertilizer, x2. Yeah. So we're not doing a problem here. It's actually an incredibly easy demonstration, yes. But maybe the output is a certain quantity of apples. One input is the quantity of organic fertilizer used. Another input is a quantity of artificial fertilizer used. So y is a function of x1 and x2. Yeah, so that's a basic example.